In Primex, the primary tool to refine the backbone is called loop refinement, or loop building. Primex uses an all-atom force field and a well-validated loop building algorithm adapted from Schrödinger's protein structure prediction package called PRIME. But, as we saw earlier, the inclusion of hydrogen atoms in the output structure is a setting that can be either enabled or disabled by clicking on the Calculation Settings button when setting up a Primex job. To perform the loop refinement, we'll click on the Select a Task button in the Primex toolbar and choose Real Space Refinement. The Real Space Refinement interface appears, and we select Loop Refinement from the Refinement Method drop-down menu. The loops are listed as rows in this table, indicating regions between organized secondary structure elements. Here's the row that corresponds to the loop in the workspace. We'll modify the residue selection to include a residue or two of the protein backbone on each side of the loop, as it's important that the fixed ends of loops selected for refinement are already placed correctly in the electron density. Primex should have no problem building the backbone through the secondary structure, even though it is a loop job. Finally, we'll check the appropriate box in the Run column to select our loop for refinement, and we'll run the calculation by clicking on the green Start button and submitting the job. At the conclusion of the loop prediction, several structures are returned to the project table, each of which is a different low-energy loop geometry that Primex found. Here in the project table surface column, we see that there's a surface associated with this output structure. This is the omit map that was used in the prediction. After doing a real space refinement, you'll probably wish to perform a reciprocal space minimization to get optimized R values. These can be performed as shown before. Primex will produce up to 5 output structures for your review, but in a large majority of cases, the top output structure produced by the loop prediction will be correct. We'll retain the top loop structure and delete the rest from the project table. The Primex loop prediction concentrates on getting the backbone prediction correct, so to follow up the loop refinement with a sidechain prediction, we'll click on the Select a Task button from the Primex toolbar and choose Real Space Refinement. This opens up the same interface that we used to perform the loop prediction, but now we'll change the method to predict sidechains. Click on the Select button to use the Atom Selection dialog to select the loop residues whose sidechains will be optimized in this job. Note that we could also use the Density Fit panel to identify sidechains that need refinement, but in this example, we'll use the residues from the loop that was just refined. Finally, to perform the sidechain prediction for selected residues, we'll click on the green Start button and submit the job. At the conclusion of the calculation, the output structure will be included in the project table and will appear in the workspace. Again, as with the loop prediction output, you may wish to follow this up with a reciprocal space minimization on the results of the sidechain placement in order to get updated R values.